cut it out, Micah.
Welcome back. Here we are. We had a student who wanted more clarification on, I believe it was the stereo center here, Y1 and Y2 here. So we'll do that. I copied the molecule here with everything we need. We're comparing from the same distance a C with nothing but bonds to C with another C with nothing but bonds to C. So we're still tied. We go to the next C's over, and we have a C with one H and two more bonds to C. Same story here, except the second bond to C is coming back. Can't count the bond that took you out, but you can count the one coming back. Now we're comparing that to these two. All right. Well, if we're over here, there's a tie between this C here and this C here. The bonding is exactly the same. They both have an H and they both have one more bond to C. So let's just call that a tie and compare this with this. We have a C with one more bond to H and a C with one more bond to H and two more bonds to C. But I see over here, these are nothing but H's. And they're the same distance away as this C and this H. So we got a tie. Need a new color highlighter here. We got a tie between this H and this H, the same distance from the stereo center. We have a winner with one more C here that this thing does not have. So that made the one on the top with the green C comparing to the one on the bottom with the greened H. All right. And some stereo centers are pretty tricky, and with the amount of time you've got on tests, occasionally it's just in your best interest. If it's taking too much time, put an R or an S down and pray for the mercy of the court that you have the right one. And then we had a question for part E and F from this exam, but you can't do part E unless you've done part C and D. So I'm not going to do this part up here. That's a lot of review. We're going to do C and D. We need C, concentration in C has to have the same units as density. So no calculator, please. That's 3 over 4 grams. 3/4 of a gram is 750 milligrams. Just in case you didn't see that, 0.75 is the divide by 1,000. That's the same as saying 3 over 4. Without a calculator, doing math with this is a lot harder than doing this. That's a decimal. So we have 3/4 of a gram over 30 milliliters. Hey, there's some simplifying you can do there. 3 over 30 is 1 over 10. 1/4 over 10 equals 1 over 40. I'm just writing big here. And L is here. L, 8 decimeters. If 1 decimeter is 10 centimeters, then this is definitely 8 times that. So now we're going to do the specific observed rotation that's corrected. Sorry, specific and corrected are the same thing, by the way. How about the standardized observed rotation? And you take the lab rotation, which is not 20, that's the lab temperature. Please don't use the temperature. Temperature's there so that it matches there always. That's the only time they're there, and you never use them. But there is the lab rotation, the resulting rotation. I'll use the same words. Negative 4.00 degrees over C, which is 1 over 40, times L, which is 8. Oh, that's nice too. See, if you buy into this fraction thing, life goes okay. 2 over 1. So it's negative 2.00. How did I get that? Well, this all simplifies to 8 over 4, which is 2. So negative 4 over 2 is negative 2. Percent EE. We can do it over here. Absolute value of negative 2.00 over 80. I don't know if my intention was to have that so small. Well, that's going to be the same as 1 over 40 times 100. 2.5%. Still having trouble with that? 100 over 40. Divide both. Both by 10. What do you got? I got 10. 100 over 40? No. Is that right? Yeah. Divide both by 10. You got 10 over 4. Divide both by 5. You got, no, that's just, well, by 2. You got 5 over 2. That's 2.5.
Sorry, could it have
Yes.
originally been negative 20 degrees for the alpha observed?
Oh, did I? Alpha observed? In the original question, did I grab
No, for C.
for C? No, the 20 is the temperature. Don't use the temperature.
No, not that. It's for for the problem C. You have negative 2 degrees. I think in the key it was negative 20.
I bet if that was the case in the key, then I changed this to negative 40. I may have done that on the key. Did you have the key open handy or no? I'll look. Let's see, where am I? Fall 19, fall 16. Where are we? Fall 16. I have it open.
I think where it was, you have negative 4 degrees divided by 1 over 4th. I think it was 1 over 40.
Oh,
Very right.
I didn't copy my own numbers right. That makes the numbers. Yes, thank you. Sorry. Thank you for being patient with me. Yeah, I didn't copy. I said C is 1 over 40 and I copied 1 over 4. What's wrong with me? Okay. So let's just redo this part here, which means we're going to redo this. Numbers are going to be a lot nicer. Need my fatter eraser. Okay, so divide both by 8. 8. And the green's got to just redraw the whole thing. I want it to be nice here. Okay. In review. Pen. 1 over 40 was the C. And the L was 8. Divide both those numbers by 8. And you get a 1 over 5. And then negative 4.0 over 1 over 5 equals negative 20, which is much nicer. And then negative 20 over 80 is 1 over 4. And it's 25%. And that's our final answer for that. And now that's 25% EE. 25% EE has one meaning only. 25% major. And don't say 75% minor. If you say that, ask yourself, did I just say that? Did I just say there's more minor than major? Because if you said minor right here, that's exactly what you said. No. This is the 75% of the solution that does not rotate light. It is the part that's called racemic. It gives 37.5% more major. And it gives 37.5% minor. we need to go back to the original part of the question and figure out, is my pictured molecule major or minor? And the answer is minor. And the only reason it's minor is that sign for the reference does not match this sign for the lab result. Therefore, the minor is this molecule. If this was a +4, then this would be the major molecule. It's not. So 37.5% of the total was 750 milligrams. Please do not freak out on me here. I need 10%, 3 times. And then I need 5%. That's 35 total. And then I need half of that. This is pretty easy math. Remember, the total 750. 75 is 10%. 225 for those two. What's half of 775? 37 and a half. What's half of 37 and a half? 18.75. What? Is that right? It is. And you're in a hurry, so I'm pretty forgiving if you just round this to 56 and then go with one I'm gonna 280. I'm gonna give you full credit for 280. You can have up to a 2% error in your final answer. And there you go. And 280 is less than half of 750. Good. And we don't have a calculator, but breaking things down to simpler percents it's actually kind of fun if you let it be. And that's 37.5%. Next one has nothing to do with molecule X, and we have 3 minutes. The general idea here is to take the mixture of enantiomers, and in this case, you're told that this enzyme will take amine Y and make it into an amide under these conditions, while its enantiomer doesn't react. So amine Y reacts. So you can do this in a pictorial form. Amine Y, react it with, don't even write stuff if you don't have to, X and Y. So it makes amide, can we just call it amide Y under these conditions? And enant under the same conditions, no reaction. Now they've got different functional groups. You just separate them. All right, so you have amide Y, and I want amine Y by itself. Does it say that? Briefly describe the steps that use this information to separate amine Y from its enantiomer. Well, you've separated them, but you don't have amine Y. And let's see, it doesn't have any clues here. So you don't have a lot of information, but you just know you have to undo. Just say some reaction. There's a nice short form for reaction. Just undo the reaction you did at the beginning. Just write it like that. So the general idea for separating enantiomers is to do a derivation of either both of them to make diastereomers, like we did in the textbook. Diastereomers are separated based on traditional methods, distillation, chromatography, whatever. After you've separated them, you got to undo the reaction you did. That works here and there. So you've got to undo the reaction you started with to make amide Y back into amine Y. And then that is the end of this process. So separating enantiomers is tricky. That's why chiral molecules are generally more expensive than achiral molecules. And that brings to a close our review day, and I hope you found it useful. And show up a little early on Wednesday, and we'll see you then.
Professor,
Yes.
are you gonna post the recording today?
Yeah, I'm gonna post it right now, right before my lunch, because I know you
Okay.
guys are all studying right now, so you need it now. And I
Thank you.
agree. So I'll make sure I make that a high priority right now. Okay.
Thank you.
All right, everybody. Take care.